So section 2.6, last section in chapter 2, it's kind of a calculus section. The concepts that we're going to cover are covered in calculus, and they're covered again in college algebra. Let's just kind of jump into it. There's a couple of concepts, and the first one is pictured here. You need to understand what a local maximum or maxima point is. Maxima and maximum, maybe one's singular and the other is plural, I kind of forget. But this dot right here I call a local maximum point because it's higher than any point close to it. It's higher than the points directly to the left of it. It's higher to the points directly to the right of it. It's not higher than that point there, but it's higher than points close to them. It's kind of at the top of a hill. A local minima or minimum, I'll use the words interchangeably wrong because I forget grammatically. I guess one's singular, the other's plural. I don't remember. It's not important. But I would call this a local minimum or a local minima point. And again, it's not the lowest point on the graph. Minimum kind of means low, maximum more or less means high. But relative to anything close to it, it's lower than anything close to it. So we need to be able to look at a graph and decide if a point is a local in a small neighborhood around the point, if it's higher than anything close to it, or if it's lower than anything close to it. If it's higher than anything close to it, we'll call it a local maxima. I'll probably call it a local maximum because it's the word that I have typed up. Similarly, if a point is lower than anything close to it, we'll call it a local minimum point. I tried to define these terms poorly. So I said on this sheet, a point is a local maximum point provided it is higher than any point close to it. Technically, a point is a local maximum point if the graph changes from increasing to decreasing at that point. That's too technical probably forever, but definitely for now because I haven't talked about increasing and decreasing. And then a local minimum point is a minimum provided it's lower than any point close to it. So we have points that are maximum and minimum points, and it turns out that the y value of those maximum and minimum points is going to be an important y value, and the local maximum value, it's the y coordinate of the local maximum point. Similarly, the local minimum value is the y coordinate of the local minimum point. So high points are maxima, maximums. Low points are minima, minimums. So the point itself, this is a local maximum point. The y coordinate of this point, whatever it happens to be, would be the local maximum value. So we have the point itself is the maximum point, and the y value, we'll get into that a little bit deeper in a bit here, the local maximum value is the y coordinate of that point, and it works for minimums. You have a local minimum point, and the local minimum value is the y coordinate of that point. So that's the first concept that we need to be aware of pictorially. The second calculus concept that we need to be aware of pictorially is increasing and decreasing. And that has to do with, as I trace to make the graph, if my marker is moving up as I trace, I call that portion of the graph increasing. There's a little arrow on this graph that points to this region of the graph. This region of the graph I refer to as an increasing region. In a bit, I'll probably call it an increasing interval, because as I'm drawing naturally from left to right, my marker is going higher to draw that portion of the graph. Similar, you see the little arrow over here saying increasing, pointing to this portion of the graph. I would also say that this portion of the graph represents another portion where the graph is increasing. For a graph to be increasing, as I'm drawing marking up the graph, my marker has to be getting higher as I move from left to right. If I had lots of points labeled, you would see in an increasing interval, each time I pass a point, the y's get larger. This arrow is pointing towards this region of the graph. And to draw this region of the graph from the local maximum point to the local minimum point, my pen is going lower. That's considered a decreasing interval. So this graph is broken up into 3 segments. Of course, there's the local maximum, there's the local minimum, and to the left of the local maximum, the graph is increasing. Between the local maximum and the local minimum, the graph is decreasing. To the right of the local minimum, the graph is increasing again. What I need to do is formalize everything I just said, because for each problem that we're going to do at the beginning of this section, we need to describe or state in terms of x, not in terms of y's, where the graph is increasing and decreasing. This is similar to finding the domain, real similar to finding the domain. And then we also need to find any local maximum points and the corresponding local maximum value. And this graph that I stole from Google kind of spills the beans on what I'm going to want to show. And I'm also going to need to identify any local minimum points points and the corresponding local minimum value. And let me jump to the max and min stuff because we already kind of touched on that. So that point is a local maximum point. It's higher than anything close to it. So for this graph, to identify the local maximum point, it's the point -216, which means any point that's close to it, its y is going to be less than 16. Some of the points have x's less than -2. Some of the points close to it have x's bigger than -2. But all of the points close to it have y's less than 16. And the author or the creator of this graph defines this. He says the local maximum value, the y value 16, which occurs at -2, it's larger than any y close to it. So the local maximum value in this case, I'll say y equals 16 is the local maximum value. I like saying it with y's. The author of this did it lazily, but it's common to do it like that. So y equals 16 is a local maximum value, and we usually tack on a descriptor of the x, and I'll say which occurs when x equals -2. That low point is the local minimum point. My local minimum point is the point 2, -16, and any point directly close to this, if you looked at their y's are going to be bigger. The y's are going to be like -15 or -14. Some of the x's are bigger than 2, some of the x's are less than 2, but all of the y's are bigger than -16. So the local minimum point is the point 2, -16, and the local minimum value is y equal -16. I might say y equals -16 is the local minimum value which occurs when x equals to 2. So that's the easy part, and you can kind of see here local minimum of negative 16. I would say y equals negative 16 occurs at x equals 2. It's just a little more informal than what I wrote. Next, I need to describe the intervals where the graph is increasing and decreasing, just like finding the domain, mostly. What I'm going to do is I'm going to break the graph up into segments. I'm going to break up the graph into the segment to the left of the maximum point. I'm going to make a segment between the maximum and minimum point, and then a segment to the right of the maximum or the minimum point. So there's a region right here to the left of the maximum point. There's a region between the max and the minimum point, and there's the region to the right of the minimum point. I need to describe these with round parentheses intervals describing the x's in those regions. This first portion, it extends, it goes beyond what we have written. It extends to the bottom of the y-axis, which has a y-coordinate of negative infinity, and it extends, because I'm going to the left, it extends to the far left edge of the x-axis. The right edge of this graph, it also extends. It extends to the top of the y-axis because it's going up. It extends to the far right edge of the x-axis because it's going right. So I'm going to describe this region, the region to the left of the maximum, using x's. This region to the left of the maximum, I'm going to say it begins at x equal negative infinity, and it goes to the maximum, which has a x coordinate of negative 2. So that first region that I have drawn in orange, round parentheses, the numbers I need are the negative infinity on the left edge of the x-axis, the negative 2, that is the x coordinate of the maximum point. And for increasing and decreasing, it's never square brackets. Don't have to worry, it's always round brackets. So that's the first interval. The middle interval where the graph is decreasing, it goes between this vertical line and that vertical line. This vertical line goes through negative 2 on the x-axis. That's the start of that interval. This vertical line goes through positive 2 on the x-axis. That's the end of that interval. That middle interval goes between x equal negative 2 and x equal positive 2, round parentheses. So I've done the first interval, described it, middle interval, now the right interval. The right interval starts at this vertical line, which has an x coordinate of 2, and it goes to the far right edge of the x-axis, which has an x coordinate of infinity, round bracket, round bracket. That's the intervals. There's two intervals where the graph is increasing. It's customary, if a graph increases in two intervals or more, to separate the intervals with a U or a union symbol. That's the bulk of what we need to do in section 2.6. There's some other stuff that's less intense. It's similar, but not so hard. So I want to pick through the problems that we have and just start digging these out. So my problem is real similar to the graph that we just did. I don't know that that's good or bad, it just is, as is yours, but it's fine because first problem, we don't want to make it that crazy. So I'm going to identify the max points, the minimum points, find the intervals where the graph is increasing, find the intervals where the graph is decreasing, and find the local maximum value, local minimum value. So I'm going to draw vertical lines for myself to separate the graph into the regions. I can already see the maximum and minimum points. They're obvious to me. I'm going to draw a vertical line through the maximum point. And I'm going to draw a vertical line through the minimum point. So I'm going to get the region to the left of the maximum. I'm going to need to define it with round parentheses intervals. I get the interval between the max and the minimum point, and then I get the interval to the right of the minimum point. As I trace on these, this first interval right here, because as I'm tracing, my marker is getting higher. This interval to the left of the maximum point is considered an increasing interval, because as if I was drawing to make this and I didn't just use my computer to do it, my marker is getting higher as I draw. The middle interval between, to draw on it, my graph is getting lower as I draw. So this is an example of a decreasing interval. And the far interval, as I'm drawing on it, my pencil is moving higher. This is an example of an increasing interval. So the far left interval always starts at negative infinity unless the graph has a period stopping it, which it doesn't here. So for me, I'm going to create this first interval. It's going to go from the left edge of the x-axis, which has an x-coordinate of negative infinity, and then my line goes through -2 on the x-axis. My middle interval goes from -2 on the x-axis to +2 on the x-axis. So this middle interval is going to be -2 to 2. And the far right interval picks up at 2, and if the graph goes on forever, the last interval ends at positive infinity. So if the graph needs to be extended, the first interval will start at negative infinity, the last interval will end at positive infinity. Now I can answer the A and B questions real easily. For A, the first and the third intervals are increasing. So this is increasing from round parentheses only, from negative infinity to -2, a union or a U, and then 2 to infinity. And then that middle interval from -2 to 2 is the decreasing interval. The maximum point is the point -2, 4. I write the whole point. It looks like an interval, but it's a point. And the maximum value is y equal to 4. The largest y value is y equal to 4. And it occurs, I guess I'm going to get lazy, when x equal to -2. There's no point close to the point -2, 4 that has a bigger y. There are points on the graph that have bigger y's, just not particularly close to that point. And then the local minimum points, that point to -4. And the local minimum value is y equal to -4, which occurs when x equals to 2. So there's no algebra. Hopefully the maximum and minimum stuff, that's just silly easy. And then it's the increasing and decreasing part that's going to be, the work. All right, move on to another example. I'm going to try to do number 4. The points that are marked, just in case the font isn't big enough, are -2, -1. That's that local minimum point. And 2, 7. That's the local maximum point. So I'm going to break this graph up into intervals. And to the left of the minimum point, between the maximum and the minimum point, and to the right of the maximum point. So my intervals here are going to be to the left of the minimum, between the min and the max, and to the right of the max. Those are my 3 intervals. Because the graph isn't marked with a closed circle on either end, it extends. And when the graph extends, the far left interval always starts at negative infinity. It will end at the x-coordinate of the maximum or minimum point. In this case, it's -2. My middle interval just goes between the x coordinate of the min and the x coordinate of the max. And my far right interval starts at the x coordinate of the max. And if the far right interval isn't marked with a period at the end, then it extends to infinity. So those are my intervals. I need to decide whether the graph is increasing or decreasing in the interval. Simple enough to do. I'll just trace this first interval that represents negative infinity to negative 2. As I'm drawing, my marker is getting lower. That's what it takes to be decreasing. I'm just going towards myself as opposed to away from myself as I'm drawing. In the middle interval, I'm drawing and my marker's moving away from me. That's an increasing interval. So it goes decreasing, increasing, and then this last interval, it's another decreaser, because as I'm tracing, my marker's going lower. I have two decreasing intervals and one increasing interval. I separate the separate intervals with a U. Now I'll just answer the maximum stuff. The maximum point, the local maximum point, is at 0.27. The local maximum value is y equal to 7, which occurs when x equals to 2. There's my minimum point, local minimum point. Some people will call them relative minimum. That's the point -2, -1. The local minimum value is y equal to -1. It's just the y coordinate of the minimum point. And we'll always tack on the x information. Get a W graph, there's going to be an extra interval. For what it's worth, on my graph, there's a minimum point, and that point isn't marked, but it's the point -1, -1. There's a maximum point. It's not marked, but that's the origin. That's the point 0, 0. And there's a minimum point here, which is the point 1, -1. I need to have those coordinates to answer any of the questions, so I just filled those in. I actually made this graph. I don't know why I didn't put the points in. Those graphs I can make. If they don't have any open circles, I can make them all day. So let me break this graph up. To the left of the minimum, between the minimum and the max, between the max and the min, and to the right. So there's 4 intervals. There's a first interval that's going to be to the left of the minimum, and then between the first minimum and a max, and then between the maximum and the second minimum, and then to the right of a minimum. I need to describe all the intervals with round parentheses. First interval, if the graph doesn't go off the screen, it starts with negative. If the graph needs to be extended, it starts with negative infinity. This one's going to end at the x coordinate of that minimum, which is -1, double round parentheses. The middle interval goes from the min to the max, which has x of -1, then x of 0. This middle interval is going to be -1 to 0. The second middle interval goes from the max that has an x coordinate of 0 to the min that has an x coordinate of 1. That we're going to write as 0 to 1 as an interval. And then the far right interval starts at the minimum, which has an x coordinate of 1, goes on to the far edge. So these are the intervals that I need to describe whether they're increasing or decreasing in those intervals. I can't do both. So the first interval, as I'm drawing on it, the interval from negative infinity to -1, my marker's going down as I draw. So that's going to be a decreasing interval. And in my answer, I'm going to put the interval from negative infinity to negative 1 as a decreasing interval. If I start drawing in the middle interval, the interval between the minimum and the maximum, my marker is going higher as I draw. So for that interval, which is the interval from negative 1 to 0, my graph is increasing. It's confusing because I have points and I have intervals that have similar values. The second middle interval, that's a decreasing interval, and that's the interval from 0 to 1. I put it in the increasing. I have two intervals, so I separate them with a U. And my last interval, my marker is going higher as I draw, so that's an increasing interval from 1 to infinity. Now I'm going to identify the maximum information. There's one maximum point. It's the point 0, 0. And for the local maximum value, I'm going to say it's y equal to 0. I'm even going to get lazier. Instead of saying which occurs when, I'm just going to say when, just to save some ink, and it's adequate to do that. There's two local minimums. The coordinates of the local minimums are -1, -1, and 1, -1. What they have in common, when I go to describe them, though both y's are -1, and it happens twice. It happens when x equals to -1 and x equal to +1. I should probably pause. Yeah, let me do one more and then I'll pause. How close am I? Yeah, we've got crud to do here. So one, maybe even two more. So for number 8, the only point that I have marked is this minimum point, the local minimum point of -1, 6. There's no maximums for this. You need like little hilltops for a maximum. So I'm going to just break my graph up into two intervals. I'm going to go the interval to the left of the minimum point and the interval to the right of the minimum point. Need to describe these intervals. The first interval, because the graph doesn't terminate, starts at -infinity, and it ends at the x coordinate of that minimum point, which is -1. The right interval begins at the x coordinate of the minimum point, which is -1, and because the graph doesn't terminate, it ends at infinity. I think I have everything I need. So first interval, as I'm drawing on it, my pen gets lower. This is a decreasing interval. So that interval from -infinity to -1, I'll put in the decreasing. The next interval, as I'm drawing, my marker is going higher. So that interval from -1 to infinity is considered an increasing interval. There's no maximums. I need humps like this to get a maximum, which I don't have. So there's no local maximum point, which means there's no or none local maximum value. There's only this local minimum point, which is the point -1, 6. And I can say the local minimum value is y equal to 6, which occurs when x equals -1. But of course, I'll get lazy because at some point, we don't write as much as we do, when it's brand new, even though it's technically brand new. Let me just do one more, and then we'll get to the second part of the video. Problem 10, the point that's marked, that's a maximum point. I don't have a minimum on this graph. Let me just break up my regions. I'm going to go to the left of the maximum point and to the right of the maximum point. Since the graph doesn't terminate, my left interval starts at -infinity, my right interval ends at infinity. My first interval is going to start at -infinity, end at the x coordinate of the max, only round parentheses for increasing and decreasing. My second interval is going to pick up at the x coordinate of the max, and the graph extends to the far right edge of the x-axis. These are the intervals I need for my increasing and decreasing. First interval, as I'm drawing over that interval, the graph, my marker is getting higher. That first interval is an increasing interval. Second interval, as I'm drawing, my marker is going down, that's a decreasing interval. That point, -1, 3, is the local maximum. That's the coordinate of the local maximum point. The local maximum value is y equal to 3, which occurs when x equals to -1. And this graph doesn't have a minimum point. So it doesn't have a minimum point, hence it can't have a minimum y value. That's a good stopping point. I'm feeling like the second half of the video is going to be quicker, but I haven't made it yet, so we'll find out when we get there.